Hey everyone, and welcome. All right, let's just dive right in. Today, we're talking about something called the Agent to Agent Protocol, or A2A for short. You can think of it as the secret handshake that lets AI agents, even ones from totally different companies, team up to tackle some really complex problems. So before A2A, you have to picture this. Every single AI agent out there, whether it was from Google, a small startup, wherever, was basically its own little island. I mean, they were powerful for sure, but they just couldn't work together. They were all speaking different languages, built on different frameworks. There was no common ground. So what did that mean in practice? Well, if you wanted to get just two agents to talk to each other, you had to build this custom one-off bridge just for them. Now imagine adding a third agent to the mix, then a fourth, and a fifth. Pretty soon you've got what developers lovingly call spaghetti integration. It's just a complete, tangled, and super fragile mess. And that really brings us to the core problem A2A was built to fix, this absolute chaos of trying to make agents work together. Without some kind of shared standard, building a real system where AIs could collaborate was, well, a developer's nightmare. And this quote from Cody Lime just nails it. They said that every single agent-to-agent workflow needed its own custom API, its own connector, basically a unique set of rules just to talk to one other agent. As you can imagine, the number of these brittle connections just exploded. It wasn't just messy, it was completely unsustainable. So how in the world do you fix a mess like that? Well, the answer isn't to just keep building more and more custom bridges. The real answer is to create a kind of universal translator. And that, in a nutshell, is exactly what the A2A protocol is. Now here's the crucial part. A2A is an open standard, and it's housed at the Linux Foundation. This is a huge deal because it brings trust and neutrality to the table. It gets everyone to agree on the same playbook. It standardizes the interface, the way they talk, not the internal smarts, so agents can collaborate while still keeping their own secret sauce. Honestly, this is the best way to think about it. You know how HTTP is the protocol that lets any web browser on the planet talk to any web server? Well, A2A does the exact same thing, but for AI agents. It's the essential plumbing for what could become a whole internet of agents. Okay, enough theory. Let's get into the fun part. How does this thing actually work? We're going to walk through the entire lifecycle of a single task between two agents because this is really the heart and soul of the A2A protocol. The whole thing really boils down to three clear steps. First, an agent has to find the right partner for the job. Second, it has to actually send the request. And finally, it needs to be able to watch the work happen and get the final result. So let's break each of these down. All right, step one is discovery. Let's say I have an agent, and its job is to find a software engineer. How does it find another agent that actually specializes in recruiting? It can't just, shout into the void and hope for the best, right? The answer is something called an agent card. Think of it like a digital business card, or even better, a restaurant menu for an AI. It's just a simple file that lists out everything another agent would need to know, who it is, what skills it has, and exactly how to talk to it. And this diagram here really pulls it all together. You've got the client, that's our agent who needs help. It uses the agent card to find the right server, which is the specialist agent. Then, boom, it sends a message to kick off a task. And at the end, it gets back what's called an artifact, the final result. Okay, moving on to step two, the message exchange. So our client found the perfect recruiting agent. Now it needs to officially ask for help. And it does this by sending a message/send request. This is the formal, hey, I need you to do something signal. But here's what's so cool about this. The message isn't just a simple line of text. It's more like a flexible container. You can have a text part, which is the plain English instruction. You can include a data part for more structured info, like a list of required skills. You can even attach a file part with a full job description PDF. It's just incredibly versatile. So the task is officially underway. But look, agent work can be complicated. It can take a while. You can't just have your agent sit there twiddling its digital thumbs. And this is where A2A gets really clever with its real-time feedback. To keep the client agent in the loop, A2A uses two main types of streaming updates. You can think of it as how it's going updates versus what I've made updates. The first one, task status update event, is the progress report. It's the other agent saying, hey, I'm working on it, or okay, now I'm searching databases. But then, the task artifact update event is when it starts delivering the actual goods, the list of candidates, for example. And that final result, as we mentioned, has an official name, an artifact.
And again, this isn't just a piece of text. An artifact can be a whole bundle of text, structured data, and files, all packaged up into a neat, machine-readable final answer.
Okay, so let's zoom out for a second. We've just seen how two agents can collaborate on one job. But the true power of A2A isn't about a single task. It's about enabling a whole ecosystem, a whole system of agents, all working together. And there's a really great way to think about this from the Cody Lime team. They say MCP helps you build a powerful agent, and A2A helps you build a system of agents. See the difference? Other protocols might focus on making one agent more powerful. A2A is all about the teamwork, about helping a whole fleet of agents coordinate on a massive scale. So when it comes down to it, A2A is that missing piece of the puzzle. It's the universal, open-source language that can turn the chaos of isolated AIs into a cooperative, powerful system. And that really leaves us with a fascinating question. If we can get all these specialized AIs to finally team up, what are the truly massive, complex challenges we could solve next? Thanks for tuning in.